Hello, Professor. I'm Madhusudan, and today I will be explaining the implementation of a stack using an array. I'll start with implementation of a stack as an array, and then I will go to implementation of a queue with an linked list. So basically, if you will see here, I am declaring a package, and I'm declaring class in stack array. Um, Public in stack array. Here I'm defining a constructor which will initialize the size of the stack array, initialize the stack array, and in the initial size is set to 0. And if you'll see, I have declared two variables, which is stack is in stack array, is an int array, and there's another variable with int size. The initial size, which is the maximum capacity, is set to 10. Now, basically, I've defined this method. Push method is defined. There's an initial check if array stack array dot length is equal to size. That means the stack is full. So I'm displaying this method double the capacity, and where defined a method where I'm doubling the capacity. If the stack is not full, or either way, it will define that it will go to um, uh, it will push an element in the stack. So suppose currently stack has 5 elements, and the size of the array is 5. So it in index 5, because it starts with 0, so index 5 is the sixth element. In index 5 it will insert the new value, and it will increase the size of stack from 5 to 6. In popping the element from the stack, from the top of the stack, uh, um, and popping the element on the top of the stack, if it says if the stack is empty, it will return the stack is empty, and the stack cannot be popped. Else, what I'm doing is finding out what is the top element of the stack, setting it to 0, and then returning the result. Now I'm also increasing the size of the stack by 1. Now I've also defined a peek method which will return the top element of the stack. It will first do a check if the stack is empty. It won't return the result. But if the stack is not empty, it will give you the maximum the top element of the stack, and it will return the result without removing the top element. Is done in pop. Now I have defined a size method which will return the size of the stack. Um, and if is empty method that is defined, it will just check if the size is 0, it will return the result, else it will return no. And I've also defined a method is full. If the stack is full, it will return yes, otherwise it will return no. Um, um, uh, Now I will jump to the main method where where I'm pushing and popping elements into the in and out of the stack. So if you will see, initially I will do the execution right now. Initially it is saying that, so I'm printing using the method if s1 dot is empty. Initially it is returning yes, because initially there is no element in the stack and size is equal to 0. So and after that I'm pushing elements 4 elements into the stack, and then I'm checking if the stack is full or not. Since the stack can hold a maximum of 10 elements, and currently it holds only 4 elements, so it is returning no, as expected. Now I'm pushing 10 elements. You'll see 6 more elements, like in all 10 elements. Now I'm checking the stack is full, so it is returning yes. And I am also putting 2 more elements. Now the number of elements in stack is 8, and now I'm checking the size of the stack. It's returning 8. Um, uh, Now what I'm doing is basically popping popping each element of the stack and then displaying the result. Um, yeah. So basically I've done that in a for loop, and if you'll see, the all the elements of the stack are returned. Elements only starting from, since two were popped earlier, so I'm, the elements starting from 55 to 100 are returned. Now I will jump to the implementation of linked list, implementation of queue as a linked list. So in this case, what I have done is I have created a package and imported the Java utility class. So now I will created a class queue using linked list, which holds the main method. But before that, I will talk about the two other classes that I have created. Um, One is a node class, which is node class which has the basics of the linked list. It has the element as well as the node 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 element which holds the pointer to the next node. So basically, um, so it has the element value and the address to the next node, which is of the type node. Um, if you see, I have defined a constructor here. Um, Sorry. If you see, I have defined a constructor here where the node will be initialized to the values from the calling program element, the value e, and next the value n. Now, um, so I have defined method which get next will get the next path of the next element which is stored in the node, and then set next will set the path of the next element to what is being passed from the calling program, and set element will set the value of the element in the node. Now I will jump to the class queue. So class queue, I have defined two objects of type node, head and tail. Uh, Initially, since the queue is empty, head is equal to null and tail is equal to null. Both of them are being initialized in the queue constructor to null. Now I've defined a method if the queue is empty. If queue is empty, because initially head is defined to null, if head is still null, then queue is empty, else return false. And now there's enqueuing and dequeuing methods that are defined. In enqueuing method, a link a node is added to the queue. So basically, I'm creating a new temp node. If you will see, it is of the type node, and the value is being passed, and the next variable will be null. Um, because the last node will temp node will act as the last node, and it will have it I mean pointer to the next node after that will be null. So now first I will check if the queue is empty. If if the queue is empty, the new node is set as the head node, and it's also set as the tail node. But if the queue is not empty, t, the new node is set as the tail node, and the actual tail that existed, the tail dot set next, the next element of next path to the next node is um set as temp, set next. So all it does is it will set the path of the tail node to the temp node, and the tail node and the temp node becomes the tail node. Now the other method is dequeuing. Basically, the element is removed from the front of the row. So basically the head is equal to head dot get next. It gets the path of the it gets the path of the next node, that is second element, and that is second element becomes the head node, and um, now then the element stored in the first node is returned in the temp. Public int size. This is another method which I have defined to find out the size. Find out the size of the size of the queue. Now basically what I'm doing is I'm looping through the entire queue and counting, looping through the entire queue until I find temp.net node which where the next node is null. And as soon as I find it, the loop exits and it gives me the count. So here I will explain the um, you know the main method is housed in this, and I will explain the main method while executing the program. So what I'm doing is um, basically creating a queue object, new queue object, and then in queuing, if you will see my queue in queue 100, 200, 300, 400. So I'm adding elements. Basically, I'm displaying. If you see the queue is empty, initially it is empty, true. The size of the linked list is 0, and then while enqueuing for each enqueue methods out statements, just to explain, element of the head is 100 and tail is 100 because this is the first element. For the second element, it will say element of the head is 100, tail is 200. And similarly you will see that I have head element and tail elements. Now after enqueuing, I'm dequeuing, and basically you will see how finally after dequeuing, uh, I have a list, I have a queue which is of size 2. Now I will move to the next, reversing the queue. In this case, basically I'm using the same method, but I'm in the main method I am calling a reverse method. Basically in the main method I'm calling a reverse method. If you'll see it, what I'm doing is I'll show you the execution here. I'm enqueuing so all these values, and then basically I am storing, if you'll see in this for loop, in another queue object which is my reverse queue. So I'm dequeuing and then enqueuing in this reverse queue. Currently it has elements in the same order now, and I'm displaying them here. Now I call this function my reverse queue dot new reverse. So now it will reverse the queue. How it will reverse the queue? It will reverse the queue using the recursive function. um, so if you see my new reverse function, what is doing, first it is it will use the recursive function. It will dequeue the queue that is passed, and then it will recursively call in the same function new reverse in the same method, and then it will enqueue. So basically temp will hold the dequeue. Suppose there are 5 elements in the queue, 5 4 3 2 1. It will dequeue till 1, and then once 1 is reached, after that it's empty is returned, and then it will in queue 1 2 3 4 5. So then that's why it enqueues in the opposite order. Now once they are enqueued in the opposite order, now I'm running a loop on my for int for the size of the queue and dequeuing in the reverse order, and you are seeing the results in the reverse order. Next I will go to the reverse stack. Reverse stack implementation is pretty simple. In this case, basically I'm using the same method. I'll show you the execution. So as you see here, I'm pushing the elements in the stack, um, and using for loop I am putting the elements, popping the elements in the temp, printing them using for loop, and then pushing them into the reverse stack.